It's an honor and pleasure to be here to talk to you, especially referring to a quite interesting topic. It's generative AI. It's nerve-touching, I would say, and especially using the Cortex AI function or feature. We were quite happy that we were one of the first in Europe to make use of Cortex AI. And to put this in business context again, it's about the answer to the question how we explore non-digitized data by means of chatbots. And honestly spoken, this is quite a game changer for us, especially talking about data democratization. I will come to that later, but this is definitely a huge asset that we can now explore. Beyond technology, beyond the use case, I would like to tell you something about the story behind the use case. That means the vision, initiatives, the breeding ground for such innovations. Because technology on the one hand side is of course important, the other thing is the impact in business. So a technology is only as good as the impact that you can create finally with the technology. So this is something I would like to demonstrate a little bit, to show you, because at the end of the day we made it to really let this innovation fly in an organization. Old grown, in a manufacturing context, nevertheless, we are able to adapt the latest and greatest AI features in our organization. First, who am I? I'm Tim, Head of Data, Models and Analytics. Firstly and officially. Secondly, unofficially, I would call myself a Siemens Energy business lead in citizen development. In total, almost 25 years in this corporation. Feel free to call me a dinosaur. There are benefits behind. 25 years in this time span, you can collect a lot of domain expertise, which is an asset using self-service analytics and all the things that are now available on the market. Beyond that, I'm a business guy, finance guy. I always say I cannot code, but based on domain expertise, based on self-service analytics, I'm able to create massive impact for the organization. So to say, I made my way in data and analytics based on passion and somehow the drive for innovation, especially talking about data and process automation. As I said, focus on self-service analytics, whatever citizens like me can handle. And the target is quite clear. Based on my role, I want to spread this virus of new way of working with data and processes. So to really unleash the potential of data and analytics and to help our organization to become smarter, faster, leaner, however you want to name it. And the basis for this is, again, digital empowerment. To say that upfront, it's all about people and digitalization, and therefore we push a lot those new skill sets, mindsets, with our digital empowerment. Good, and finally, I'm always and still very impressed, day in, day out, about the power of citizen development and how a little group of passionate people can create such solutions. To say that we were a group of 3, maybe 4 persons that made that happen. So Markus will introduce himself later on, but in essence, that was great. It only needs a few people to drive innovation. This is my statement here. Where am I from a business perspective? So Siemens Energy, that's clear, but let me explain to you Siemens Energy, the trends, our portfolio, and I would like to build a link between an old-grown, maybe old-fashioned company doing something with energy and this hype industry around data analytics and AI. There's a quite interesting link. Give me a couple of minutes, I will explain you why. Trends and portfolio. Talking about trends, very simple. There are 4 trends that at least we are facing in energy business. First of all, it's the pure demand of energy. Secondly, decarbonization, decentralization follows, and digitalization. Talking about digitalization in this audience, I would say this is clear. I don't have to explain why we need this. I would say the same applies for decarbonization. I mean, we see it. We have dry summers, we have fires, we have floodings. Recently we had heavy rain in Germany. I mean, there is something going on outside. Then, of course, we have decentralization. This is something, just to explain this. In former days, energy was produced centrally. That was a different story for the grid to distribute energy. Nowadays, we're getting windmills here and there, so it's decentralized, heavy impact on the grid. The grid needs to be more flexible. Just to explain you this trend a little bit. And now coming back to the demand, there are forecasts that we need 50% more energy by 2040. So let me do the following equation to link energy with the new world, with data. One blockbuster on Netflix is worth one medium-sized transformer leaving our factories. What does it mean in tangible figures? If we talk about a transformer, we talk about 90 tons of metal, oil, copper, paper to run Netflix for you. And the second equation would be, talking about AI, if AI develops as forecasted, AI will need more energy than single states or countries in Europe, like Finland, for example. This is massive. So this is the link between us, Siemens Energy, putting the lights on, or the data centers on, and our passion for data and analytics. Portfolio, we are an integrated energy technology company end-to-end. That means from power generation via storage, via transmission to us, households, and to the industry. And we are a global leader in energy business. You can find us in more than 90 countries. We have meanwhile close to 96,000 employees growing based on all the circumstances that are out there. 1/6 of the global energy generation is based on our technology, and more than 50% of our portfolio is relevant for decarbonization. Green energy. What else? Vision and initiative. Why? I just said it. Technology is nothing if you cannot implement technology in a business. Therefore, we have a vision, and our vision is called the 6-step approach. In a nutshell, we want to move our network of manufacturings, 30+ factories worldwide, into the state of smart factories. It starts with the question how we collect data, how we connect data, how we learn from at least past and present, and then of course it goes into the hype arena of predictions, correlations, and AI. Of course, this is a kind of transformation, and this transformation does not take place in a vacuum. It affects the main assets of a company. And the main assets are data, process, and people. Mistake here is people should come first, because just imagine if people don't transform, forget about data, forget about processes. So we consider people as a key success factor in this transformation. On the innovation side, like us now standing here explaining you Cortex AI, and of course on the adoption side. So, I mean, our features can be cool as whatever if nobody is interested in that in the business. And then, of course, the question is how to connect those assets, and there is the place where citizen development comes into game. With citizen development, we connect data, process, and people. We are connecting all those little dots between those assets. And why? At the end, we want to unleash respective power and innovation. And here you see all those logos. We take whatever is simple and easy to understand and implement by people like me from the business. That means Snowflake, UiPath, Alteryx, Tableau, Mendix, you name it. Power Automate, we all like that and we apply that. And talking about analytic process automation, to give you a little bit more insights, I mentioned this here. It's a digital catalyst to create business-focused, hands-on, fast, and economic solutions. So what does it mean? Enablement in principle means we have specific learning path for people that want to go into data and analytics. We offer internally trainings online and on-site worldwide. We perform hackathons worldwide. This is what you should understand by reading enablement. Talking about ecosystem, we created an ecosystem which is easy to access, which fosters data democratization and data literacy. Talking about data literacy, this is something where Snowflake comes into play again, because we made it happen that all our data workers, by drag and drop of a little macro into Alteryx, can make use via Snowflake make use of our ERP data. This is massive. So if you build a data model now, you can really easily scale it based on your ERP data. So what else belongs to ecosystem? Ecosystem is community. We have 2,000 data workers only in Alteryx. And of course, we have a solid and a fixed and firm operating model. At the end of the day, our department is a center of excellence, driving everyday citizen development, telling people how to improve their way of thinking, upskilling, and so on. Whoever wants to read the details, here they are. On the right-hand side, I'm always asked, what is it good for? Benefits. So benefits of our setup is, first of all, a higher level of automation. Secondly, end-to-end, always from data source, data preparation, up to whatever result, chatbot, email, dashboard. It's about upskilling, it's about learning path, it's about, as I said, mindset, and of course, connecting data processing people. Talking about numbers, because I'm often asked for numbers, just to give you the tip of the iceberg. So we got roughly 250 use cases reported back out of our organization, and they are worth more than 300,000 manual hours. That means if somebody shuts down our system now, then we would have to invest 300,000 manual hours again to create the same result. Of course, consultants don't want to hear this, but getting smarter, we need less external support. Yeah? We become smart and we don't remain the sidecar passenger in the digitalization, which is, of course, important for us as a huge organization. Here are the details. Drums, please. First, the use case, and especially the first part of the use case, because what we did is a kind of synergy between two technologies or providers. It's Alteryx and Snowflake, and the case is very simple. Just imagine moving boxes full of paper, something like this. And the task was now, or the challenge was now, engineers, they needed the information of those moving boxes or the paper in the moving boxes. We talk about 700,000 pages, still growing, up to 1 million. This is what we want to tackle. And the problem now is you can read this manually. Little calculation, you would need 4 years, this is our assumption, to read 700,000 pages, just cross-reading. Of course, not possible. So let's do the next equation. So we are in fuel cell system business. We are in R&D. This is our data input. On the output, what I just said is data democratization to make this data treasure available to others. So we have unrestricted up to strictly confidential data because we talk about future technology. In the middle, talking about the way how we made it, we used Alteryx for OCR, ETL process, and then afterwards we take Snowflake with all the new features that are out in the market. And of course using generative AI, creating new content. And I would say we created a setup which is quite transparent, using crowd intelligence. Markus will show this. There's a feedback loop that everybody who uses the chatbot can learn from it. And of course, it's intuitive. It's just the UI. People go there, they don't see any Alteryx, Snowflake, any data, they just get data. Yeah, that's it, basically. Looks always simple. A lot of time has to be spent on data preparation. This is something I can share. Of course, you could now argue why they use still Alteryx. We use it because it's easy for us. Our entire community talks this language. But of course, we could shift the Alteryx job later on into Snowflake, based on use case, based on volume of data. That means using document AI container services, for example. Okay, benefit, less reading and optimized resource allocation. We talk about PhDs. They are expensive. So 20 PhDs are not anymore going through paper. And of course, for us as company, it's a competitive advantage because we now made use of this data treasure. And without giving details away, because We talk about future technology. We had some cost and design reviews, and those reviews were based on the data that we have now available. And we believe that we will have soon in future a very sellable product, which is of course a strategic advantage for our entire company. So the Alteryx job, very simple. We have paper documents. What we did is we collected them. We did computer vision PDF to text using existing OCR layers. So what we did then with Alteryx is an OCR optimization. And at the end of the OCR optimization, we were comparing those two OCR results. And of course, we were taking the better one. And finally, you can imagine, Glenn's data, improved OCR, goes into Snowflake and creates the basis for whatever happens afterwards. Again, data preparation, 80% of our time was spent on data preparation, doing this job. And of course, I can tell you that there is, of course, a cost-intensive step, which is not maybe that visible here, but if you talk about paper, you have to OCR it first. And we talk about bunches of moving boxes. So this was really this was expensive, performed by a third-party company. You should take this into consideration. Digitalization is not for free. You have to pay sometimes to OCR paper. But the benefit is this use case can be reused. It's a governed use case concept, what we have. It's a service to all our factories. So therefore we say scalability is high, and sometimes it's worth to spend money and learn with new technologies. And having said that, again, drums please for the second part of this use case, the Snowflake part. And having said that, I hand over to Markus, our valuable Snowflake consultant that supported us a lot.
Thank you very much, Tim. I'd also like to say hello from my side. My name is Markus Schäfer, and I'm a solutions consultant at Snowflake Professional Services. In my role, I really enjoy working with new technologies, and I also like to be hands-on from time to time. So that is why I was really excited when I heard that I could support Tim and his team with this document Q&A or speak to your documents use case. Using the experiences that we gained from this project, I will now talk you through the process of the implementation of this solution for this specific use case. I will also show you the chatbot in action at the end of my presentation. Now, before we talk about document Q&A with Cortex AI and Streamlit in Snowflake and the implementation, I would also like to note that, of course, when running and doing such a project, what you first do is you don't start with the implementation straight away. First step in such a project is always to gather the requirements, talk with users, analyze their needs. So for you to better understand the context here, I've brought with me here a summary of the requirements for this use case, summary of the requirements impacting the solution architecture. The first requirement that I want to highlight here is that it should be really easy, cost-effective, and fast to always add new documents to a solution. What the users wanted and what the team wanted is, let's say, an automated process so that a process can detect whenever there's a new document, so that this new document can then get made available to a chatbot solution in an automated fashion. Next, for transparency reasons, the users, they also wanted to know which pages, which documents, and also which pages were used to answer their questions. They also wanted to have a link to the raw document, so whenever they interact with the chatbot and then they see the sources that were used, they wanted to have a link so that they can then click on the link and a PDF would open in the browser next to the chatbot. Security and governance was also a major topic for this use case, as we're talking about confidential, sensitive data, research documents that maybe also include intellectual property. This was then also a requirement, of course, that the data does not leave Snowflake, the secured Snowflake environment at all. Since the team that we were building this with, Tim's team, and then also the users are, I would say, a rather small team, they were also looking for something that a solution that is easy to implement, a solution that is easy to implement and doesn't require a lot of maintenance. Maintenance, when we talk about maintenance and something that should be easy to implement, what we think about then is a managed solution. So we were looking for something managed. And managed is also a really important aspect for the next requirement, because as you can see here, time for a proof of concept which actually was rather a MVP than a proof of concept. We had about 3 to 4 weeks when starting this project for the first MVP, and we started in the beginning of the year where it was not as simple to create such a chatbot solution. We had about 2 people working on this project for 50% of their time. Okay, so now with all that in mind, it was then time to think about how we would get the information from the documents, the knowledge that is inside the documents, available to a large language model. What you can see here are different approaches of how one could achieve that. So adapting large language models to the use case at hand. On the y-axis, you see the complexity. On the x-axis, the time that it takes or the maturity that is needed to work with the respective technique or approach. Due to the fact that training one's own model is really, really complex, it requires a lot of resources and time, that option, the last option, pre-train your own models, was not viable at all for us. Also, the first option, prompt engineering, it cannot really be used to inject a large amount of knowledge to a large language model. So the only 2 options available then, and where we focused on, is retrieval augmented generation, RAG, and fine-tuning existing models. Then considering the requirements, the advantages and the disadvantages, we then have chosen to work with RAG, retrieval augmented generation, as a technique. We wanted to start with that and then have that as a baseline for further improvements. So this decision was mainly made to the requirements and the time and resources that were available. I'll briefly try to discuss here and give you an information, an overview of what retrieval augmented generation is. It's basically a technique that allows you to make your company internal documents available to off-the-shelf large language models. So there's no need for training or fine-tuning with retrieval augmented generation. With this technique, what you do is you first build a knowledge base of your company internal documents. A knowledge base with your company internal documents, and these private documents, of course, they're unknown to any off-the-shelf large language model. So what you do is you build a repository. In our case, it was a table that holds information. The text is there, and also the vectorized version, so a transformed version, not only the text, but also the text in form of vector stored in this knowledge base. That's the first point. Then whenever there's a user question, a user interacts with the chatbot, what will happen is that there is a retrieval engine that will first search for relevant information in this knowledge base to answer the user question. Then after the retrieval engine, what we do here with the RAG approach, how this is done, is we build a prompt. A prompt is the combination of the user question, the instructions, meaning the prompt engineering part, so how the model should behave, specific to the use case. And then, of course, the context, what we have found via the retrieval engine to be relevant to answer this question. Then, with this prompt, the large language model is then able to answer the question. Okay, so now what are the pros and cons for this approach? The first advantage is that with RAG you always have up-to-date data because of the fact that you don't need to train, you don't need to fine-tune. What you do is you just transform from a text to a vector, then the text is in your knowledge base and you're good to go. So always up-to-date data. Second point here, cost efficient, because you're using an off-the-shelf large language model. There's no training needed again, and because of the retrieval engine, you really know what sources, what documents were used to answer this question. Disadvantages include that there's a context length limitation. So as some of you might know, there is a token limit when working with large language models, and then of course you cannot fit your whole knowledge base inside a single prompt. So there's a limitation in that sense. There's also added latency because we now have the retrieval engine and the large language model. And in general, I would say also this could be a disadvantage, that heavy dependence on the retriever part. So there's not only the large language model, but also the retrieval engine that is important. Okay, so when we knew about the requirements and that we wanted to work with this RAG approach, it was then time to think about how we could implement a solution on Snowflake. And since we were looking for a managed and easy solution, we immediately thought about the combination of Cortex AI and Streamlit in Snowflake. With Cortex AI, we could choose from a number of different large language models that were hosted and managed by Snowflake. Although Snowpark Container Services was also an option on the table to work with large language models in Snowflake at that time, we really preferred to work with Cortex because it is the simplest way of interacting with a large language model in Snowflake. Having a look at this overview here, you can see that there is an outer border which indicates that a requirement for us, which indicates that there is, let's say, a border around this whole environment that indicates that the data does not really leave the Snowflake environment. So this was one of our requirements. We were really glad to note that even when working with large language models, the data does not leave Snowflake, everything stays in the same account. And then looking at the bottom, you can see the Snowflake governed data, which acts as a foundation for everything else. And then what we did is, building on this foundation, the data, we worked with 3 different serverless functions, Cortex functions, the translate, the embed text, and the complete functions, to interact with the task-specific, the embed, and the foundation models. In the middle of the screen, you can see Cortex Search, which you can use as a service for the retrieval engine of the RAG approach. And at the bottom, at the top, you can see Streamlit in Snowflake, which we used to implement a user-facing application, so the chatbot interface. Okay, so now with all these parts of the chatbot, Streamlit in Snowflake, the retrieval engine, and also the large language models running on Snowflake, we have all the parts that we need for a chatbot on a single platform. This, of course, then is really an advantage. We don't need to move the data, and this then allows in general to be, let's say, an easier and a simpler solution, a more governed solution and a more secure solution, because you're always in the same platform. Now let's have a look at how we implemented the solution in more detail. RAG at Siemens Energy with Cortex AI and Streamlit in Snowflake. What you can see here is the first part, which is about creating the knowledge base, the vector store. We start with the documents text available in a table. Initially, we had 1 row per page, but as I've already said, there is a token limit when working with large language models. So what we had to do is we had to split the documents and the pages into more chunks, so smaller text parts. For that, we implemented a user-defined function that we implemented with the Snowpark API in Python, and we also used the LangChain text splitter module for that. Then, after the chunking, what we had to do, because we didn't only have the English text, but also German text, we made use of the translate function, the Cortex translate function, to translate the text that were not in English, were not in English to English, so the German text in our case. After that, when we have all the text available in English, we were then ready to use the embed text function to get from a text to a vector. So the vectorization or the embedding. An example of such an embedding can be seen here on the right side. IAM example string is here the example, and then the output is a vector, and this vector can then be stored in a table using the data type of vector. So at the end of this pipeline, then here we have the text available as a vector stored in a table with the column of data type vector. Of course, this can also be automated then via tasks. Now, if there is a user input, a query in natural language from the user, what we do is, again, we translate first to English, because with this translating to English, we allow all the users to interact with the chatbot in their native language. We again translate to English, again do the chunking, so that we now have both sides, the question and the vector store, in the vector space. And then in the vector space, we can then check for the similarity, find out what is relevant. Therefore, we use the vector LT2 distance function available with Cortex. So now when we found what is relevant, the next step, of course, is to build the prompt. We found out what is relevant. Next step, prompt, meaning we take the question, the instructions, so we do the prompt engineering specifically for our use case. take that all together in a prompt, and then we use the complete function, the Cortex complete function, to interact with the large language model, which then, using this prompt, is able to answer the question. Now, here, the whole response of this large language model, meaning the question and the answer, but also metadata, is then logged and forwarded to our Streamlit in Snowflake application. Streamlit in Snowflake application that we implemented with the SD chat components, meaning the chatbot components from Streamlit. In addition to just the chat history, we also have, as I said, the direct link to the raw documents. We have the dashboard available that can show you the feedback that was given by the users. So there's mandatory feedback in our chatbot. And we also have a list of the last questions and answers. Now, before we jump to the demo, I would quickly like to talk about the process of selecting a large language model. What you can see here are different models that were available in April of 2024. So this is not the current state, but it doesn't matter. What I'm trying to say here is that in general, you will see small, medium, and large models. And what's important when choosing a model is, of course, the reasoning quality, the reasoning speeds, and most of the time, also a really important factor, the cost. So which model have we used for our chatbot? We have first started in the beginning of the year with the Llama 270 billion large language model, but later on we moved to the Mistral 8x7b model. We've of course also tried the larger models. As you can see, we kind of were focused on the medium models. We also tried the larger models, but we found that there is not really much of an impact or a difference when choosing to Mistral large, for example, in our use case. So additional considerations here with RAG are, for example, that you want to have a model that has a large token size. This was one of the reasons why we then switched to the Mistral large language models, because they have a really high token size. But the key message here that I want to highlight is it doesn't only depend on the large language model if you use the RAG approach. The RAG approach consists, of course, of the retrieval engine and the large language model. What you can see here, and is always highlighted with the numbers here for a specific benchmark, is the large language model part. It's not the part that includes the retrieval engine. The retrieval engine is completely missing in those benchmarks. So, of course, then it also depends on the retrieval engine, and if you feed a large language model the wrong information, it will, of course, have a hard time to answer the question. So that's really important, the retrieval engine as well. So one could say garbage in, garbage out also applies here when working with large language models. Good, then let's move to the demo. Good, here you can see the interface that we built, the FCD bot, fuel cell document bot. You can see on the left side here, there's a navigation. We have a multi-page app. We have an area for selecting the functionality, for models, for the text reference and the number of words we want the answer to have. But the most important part, of course, the main area here in the middle, where it says, hello, my name is FCDbot. Please start by asking a question below. So that is what we will do. I'll first ask a really open question to introduce the bot to you. Who are you? And it now will take about 5 seconds for the bot to answer. And as you can see here, there's already the answer. I'm FCDbot, the document Q&A bot specialized in the field of fuel cell research. Okay, now good answer. So we provide feedback to the bot, feedback that we can maybe later on use for fine-tuning. Another question that I can show you here with this demo is, what is a SOFC? So this time the knowledge base has to be used. And the SOFC, maybe I'll wait for the chatbot to answer, but as you can see, a SOFC, a solid oxide fuel cell, so a type of fuel cell. You can see that there is a detailed answer here and a summary even, and then also really important, the sources. The sources, the documents with a link to the relevant document. You see the page and also the similarity. Good answer again. Good. And also for document Q&A, I want to show you that the chatbot is also able to give an answer for questions that require a lot of information from the knowledge base. What are the sulfur content for SOFC? So one could say a follow-up question. What are the sulfur content requirements for SOFC? So now it not only has to know what a SOFC is, but also we are interested in a really detailed part. And you will see, of course, now the answer was really fast. 0.1 parts per million is the answer, and again, we also have the sources available here. Good. Then having a brief look here at the statistic, I want to show you here that we also have this dashboard available here. You can see we currently have about 16,000 files and 1.3 million embeddings with this chatbot here. We see the model performance, usage, and feedback as well, where, for example, we can see here the execution time for each model. We can see that our current version has it takes about 5 to 10 seconds to answer. And of course, then also the questions over time for each user. And really important for us to consider if we've made progress with newer versions of the chatbots, the feedback percentage by model. As you can see here, for the last complete version 5, we made a lot of improvements, received a lot of good feedback here. Good. And yeah, I think the question log, I can show you that because in this demo I can show you that because it may contain sensitive information, but what I can show you here, the last page, documentation. So for users that are interested, of course, we also have a documentation here. And with that, I'm at the end of my demo here, and yeah.
Okay, so this is what we saw. And then we are basically at the end of this presentation. The only thing I would like to share is an answer to the question why. Why do we believe was this overall approach good? So to say, our cookbook and all the ingredients that we consider as positive. And again, what I would like to do is I would like to differentiate between technology and the environment, the breeding ground. So talking about technology, here's a little summary that we compiled regarding the positive items based on the tool stack that we've chosen. Just to highlight, for us, both vendors are a tried and trusted approved platform, so we are allowed to use it. Of course, multi-LLM is a kind of beneficial for us that we can switch. It gives us flexibility. We have flexibility on the ETL side with Alteryx. We have scalability in Snowflake. That's a benefit. The professional services from Snowflake, of course, were a big benefit. And again, talking about people, we have a huge native data and analytic workforce already. So this is key because taking a technology, giving it to a native DNA group, this was a success. And this is the bridge to our ecosystem, analytic process automation and the citizen development. What we did is we, as shown, in a couple of weeks, we created a solution. We were fast. We had the impact. And why did we have this kind of speed? Because we had the domain expertise. I'm coming back to my 25 years, the dinosaur. We had the domain expertise. We're close to business. We understand what they need. This was key. We were thinking outside the box, end-to-end, from data up to the desired result. We even trained people on how to prompt, how to ask a chatbot, because this makes the difference. So therefore, great story. At the end of the day, we have a solid business mandate to roll the solution out throughout all our factories worldwide, 30 plus factories. And therefore, we're quite happy to have the solution now running. There is a pipeline regarding new use cases. Just to give you some ideas, we do see potential in our test field reports to chat on test field reports, to chat on other technical drawings, construction and production procedures, in sales, lessons learned documentation, most likely PowerPoint or whatever, or any kind of offer documents, tenders from customers. This is something we now look into using the chatbots. Having said that, this is really the end. Thank you very much for your attention.